Okay, so in lesson 4 we have 2 learning goals. Okay, the very first one is what we're going to cover on this first side. I can write algebraic expressions. Well, oftentimes when you have to write algebraic expressions, they come from a word problem. And so then you have to understand how to translate those words into an algebraic expression. So we really already have some practice with this. This really should not be new to us. But what we are going to do first of all here is we're just going to give some words or word phrases that help us understand which operation should be happening in our expression, our algebraic expression. So can you give me some key words that are kind of like for you, they say, I need to do addition in this one. What are some key words that would say to you, I need an addition sign? Danny? Plus. Yeah, I think the word plus is a pretty good one. You know what, let's put them down on the line below so that we can kind of see that. Wait. Sum, like, could you spell that for me? S-U-M. S-U-M, that kind of a sum. S-U-M. The answer you get when you add is a sum. S-U-M, not the other sum, okay? Okay, let's get a new volunteer. There's lots more words or word phrases we can come up with for addition. Come on, let's try. If I let Danny answer again, I am not going to probably let Danny answer too much more, so you guys better step up to the plate before I call on you. These are the easy ones, I think. Addition. Sierra? Add. Yeah, we could just say add or added to. How about we use added to? It's got the word add in it. That kind of, 6 added to 4. Or, did you have one, Caden?
No, I thought it was one, but it wasn't.
You said it wasn't a good one?
I was going to say total, not subtractions.
Oh, yeah, so sometimes, using the word total is kind of hard because you could have to subtract, you could have to multiply, so that sometimes total oftentimes we do end up adding, I will agree with that. Okay, I'm going to help you out here. I'm going to say, if you see the words more than, that's indicating you need to add. If you would see increased by, that's indicating to add, increased by, so increase something by a certain amount. And then I'm also going to use the 2 words greater than. Now, I want you to notice there's a difference between is greater than and greater than. So before you write, can you just listen up for a second? 4 greater than 4 greater than 3. 4 greater than 3 does not mean the same thing as 4 is greater than 3. Why not? 4 greater than 3 does not mean the same thing as 4 is greater than 3. Anybody know what the difference is? Like, why is that such a big deal? All I inserted was the word is in front of greater than. Wait?
4 is greater than 3 would be comparing 2 numbers.
Yeah, that's making a comparison.
4 greater than 3 is like 3 plus 4.
Or 4 plus 3, right? Yeah. 4 greater than 3 means add them together. And it doesn't matter. Does order matter in adding, by the way? Order matter? No. But when we stick that word is there in front of the greater than, is greater than, now we're making a comparison of numbers like Wade said. So it means 2 different things. So do not put the word is there, just put greater than. If we don't see the is in front of it, we can probably count on that we should be adding. Danny? Okay. Combined. And we don't have to put 2, we could just put the word combined. Because oftentimes probably the word that we use with that is with, okay? So if you want to put a word with combined, you can put combined with, okay? Okay, that's a pretty good list of words or word phrases. Now, it doesn't mean it's the only ones, but it's a pretty good list for us, isn't it? Okay, let's try subtraction then now. Let's try some words or word phrases that would indicate to us that we want to subtract. Harley, what's one? Less than. What do you think we better be careful of there? Less than. Is there another way that that could be possibly, those words could be used and it would not mean subtraction? What do you think, Katie? Is less than. That again would make it into a comparison. So we have to be careful. We don't, if it says is less than, there's a comparison going on. If it says less than, there's a subtraction going on. Okay. Sammy?
Minus.
Minus. Yeah, that's a really common one. Minus. Danny? Take away. Another word or phrases would be kind of a good indicator to you that you should subtract. Sierra?
Less than.
Less than. Okay, that we already have that at the beginning of our list there. Katie? Decreased by. Yeah, instead of increasing by, now we're decreasing by. That means we better take away, we better subtract. So decreased by, wait,
Taken from.
taken from, okay. And it seems like if we were taking, we're subtracting, aren't we? Danny? Separated from. Well, oftentimes we probably won't see. I mean, it kind of could mean subtraction, but I don't know if we would very often see the word separated used with subtraction. Typically, it would be more for division. Okay. Tell me what the answer is when you do a subtraction problem. What's that called? What's with the D? It's kind of a long word. It has, again, let's see, I can't even picture my head. 6, 7, 8, 9. Yeah, I think it's got 10 letters in it. We're on the Wheel of Fortune now. Starts with a D. It ends with an E. Has a couple of F's somewhere in the middle. Okay. Difference. Good job. That's a big one. We have to make sure that we understand that when it says difference, the difference of, we're talking about a subtraction problem. The answer we get when we have a subtraction problem. Danny? Yeah, you know, the simple word of subtract, right? I guess I got room right here. You put where you have room. Subtraction, if it says subtract, well, that's a pretty good indication that we better use subtraction. Oh, I use decreasing by instead of decreased by. I'm gonna change this. So if you copied me, you know, you're gonna have to copy me some more now. Decreased by. Now I didn't want decreasing by, but I guess it would be a bad deal. Okay, let's move on to multiplication. Wait, you're ready.
I had one more for.
Oh, you had one more for subtraction. What do you want to add to that list?
Subtracted from.
Subtracted from, yeah, we could take that one also, subtracted from, if you want to add that in your list. Subtracted from. Okay, again, we can come up with lots of these, but, you know, and some of them, if you're feeling like, you know what, I know those, that's good. But let's move on to multiplication now. Harley? Is take away multiplication? No. Like, give me an example. When do you think it would mean multiplication? Okay. Sierra, let's start over there. Times, yeah. So they use the word times. You better multiply. Danny. Multiply. Okay, so usually they don't say 6 multiply 7, they say multiplied by. So let's write it like that. Multiplied by. think of some other ones. Let's go back to that word separate. What do you think the wording would be if they meant you should multiply? Do you think separate could be used? Or not? Should we save that for division only? What if they said something like this? 8 separate groups of 4. And they asked you to tell us how many there were of whatever they were talking about. Let's say they were talking about candy bars, they had piles of candy bars around. And they had 8 separate groups of 4. What would you do to figure out how many candy bars there are? You multiply, wouldn't you? Okay, so I think we could do that. Separate groups of. Now notice I didn't say separated. Separate groups of. We always want to include the word that means the answer you get when you do an operation. What's the answer called that you get when you do a multiplication problem? Got it, Wade? Product. Yeah. Product. Product of 6 and 2 means you better multiply those fellas. Okay? Can you think of anything else that might indicate it? Any others? Mrs. Allen, Ms. Borg, you guys would like to contribute? No, you know, for multiplication. Anybody? Think so? Think we can quit in that list? That one doesn't seem quite as long, does it? Okay, I am going to add another one here, and it kind of goes with that, separate groups of, but let's put it like this also. Put together equal groups. Put together equal groups.
Like separate equal groups.
So, not separate, but put them, so we have all these equal groups, and if we want to know how much there is altogether, it's kind of like you could just multiply, right? Wait, you got another one? Multiplicative. Well, multiplicative would not probably be used in a word problem that would indicate, that's a property, there's such a thing as some multiplicative properties, but we wouldn't say something like 7 multiplicative of 5. We probably wouldn't say that. We would say something like 7 multiplied by 5, or the product of 7 and 5, or 7 times 5, but yeah, it's multiply is part of that word. Okay, division, let's move there. Sierra. Divide. And usually, we don't just say 7 divide 2. What do we say? 7 divided by. So let's make that divided by. Just like when we said multiply, we don't typically just say 7 multiply 2. We say 7 multiplied by 2. Harley. Separate. Oh, so separate though. We got to also be a little bit more into what? Separate, Kaden? Oh, into equal groups. Because if I'm going to take 10 and I'm going to divide it by 2, I'm going to be separating it into equal groups, aren't I? So separate into equal groups. Okay, we're ready to get all caught up here before we carry on. Some people I still haven't heard from. Hayden. Dividend. No, one of the parts of a division problem is called the dividend, but it is not, it's just like that's one of the parts of it, but it doesn't really necessarily mean divide. Carly? Equation. Well, an equation can have a division in it, but it doesn't necessarily mean divide. Equation means an expression set equal to another expression. And in one of those expressions there could be, or in both of them, there could be division, but it doesn't have to be. So we need something that you have to make sure you use division. Okay, the $100 question again. What is the answer you get when you divide? Mrs. Allen knows, but I'm not counting on her unless you guys can
I feel like I need to redeem myself for having nothing to contribute.
Did it catch you on the spot, didn't it? Oh, darn it. Can I give them one clue? What did you say, Harley? Quotient. Oh, good job. Quotient. 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 So we always have to make sure we talk about those important words. Addition, it is sum. Subtraction, it is difference. Multiplication, it is product. Division, it is quotient. Okay? So this is one that it's kind of hard to separate. Hey, how do I spell separate? All of a sudden I went brain dead. Is it S-E-P-A? It is. I think it is.
Separate would be, you're separating two people, or separate would be it's on a separate sheet of paper.
This is what I do when I'm just not sure, because I do not like to not be a good speller. So if I have to look it up, I will look it up.
I think it's an A.
Do you guys ever use the dictionary anymore? On your phone you do. Oh.
No, I use that.
Separate. There are no separates. No, there are no separates. We're gonna change those to A's. Oh, I can't be teaching you guys how to spell improperly. That would not be good. Okay, so if I wrote it there, we wrote it here, we're gonna change those to A's. A. Okay, separate. Okay. Well, now that we got our English down for the day also. Okay, are we good? Do we have any more for division? Okay, well now we're going to translate some words then into expressions, okay? Now that we know some of those key words mean what to do. Okay, so, get this back up here so that in case somebody still didn't get their separate spelled right. Okay, number one, a number decreased by 4. What do you want me to do, Harley? Subtract. Okay, well then what's the expression going to look like now that we've decided which operation to use? We got to write an algebraic expression. IKEA? X minus 4. A number x, subtract like Harley says, and it says decreased by 4, so we need to subtract 4. Now, I have an important question for you. Does order matter in subtraction?
Yes.
So, would it be okay if we wrote that 4 minus x? What do you think?
Yeah.
Yeah, it's a bigger number on top.
How do we know which one's bigger?
Because X is
Has X been talking to you? You know that silly X, we never know what X is, do we, until we can figure it out somehow. Well, if order matters in subtraction, we can't flip that around. We have to write it in this order. A number decreased by 4. This is the only way we can write it. Well, number 2. 4 less than a number. An algebraic expression can be written for that one. This is so important that we understand how to set these up properly. 4 less than a number. This is a tricky one. That means 4 minus x. So is this the one that I get to write 4 minus x for then? Yeah, that's, you know what? Lots of people are tricked into thinking that, but that's a no. Sorry. Here's what, it's the one set of words for subtraction that is very tricky. A 4 less than means 4 needs to get subtracted from. It's kind of like you can think of it as subtracted from. So a number, we start it like this, it ends up looking just exactly like the previous one did. This is a big deal that you understand. These words, these subtraction words are kind of like, they don't go in the order of the expression doesn't go in the same order as the words do. Okay? Now let's try 3. A number subtracted from 4. What's going to start our expression? A number subtracted from 4. Would it be this? Would it be that? What's being subtracted in this one? 4. The 4 is being subtracted, isn't it? It says the number is supposed to be subtracted from 4. So guess what? This one doesn't follow the order of the words either. This one says, no, start with the 4 and take away from it the number. Subtraction is the trickiest one there is. You have to be really careful and think through it. Anybody want to ask questions about any of those? Or? Okay, number 4. 3.5, 3.5, 3 5/10 divided by a number. How could we write that? I'm going to say that there are 2 different ways. Katie, what's one way?
3.5
Okay, 3.5 divided by x. Is that what you mean, like that? Did I write it the way you want?
Yeah.
Okay. There's another way we can write that. Hey, by the way, does order matter in division?
Yes.
In other words, is 10 divided by 2 the same as 2 divided by 10? No, it's not, is it? So order does matter in division. Harley?
You use a division sign X on the outside.
I'm sorry, say that again.
Like the division sign. You know what I mean?
Yeah.
And then with the 34 sign X outside.
Oh, like showing it as an actual long division. No, that's not typically how you would see it. It's how would it be in an equation? And they would not show it this way. So this is what I understand you are saying to me. 3.5 divided by x. Yeah. They would not show it that way. That would not be considered like an algebraic way to write it. Okay? But that is, you're right, that is one way that we could set it up. Okay? What does the fraction bar mean, you guys?
Oh,
What does the fraction bar mean?
divide.
Divided by. So 3 over 4 is also, besides saying it's 3/4, it means also 3 divided by 4. So we could write this 3.5 over x. 3.5 over x, meaning 3.5 divided by x, means the same thing. Can't flip those around though. It can't be x divided by 3.5 because that's not what it says. Okay, Danny, tell me what I should write for number 5. 2 more than a number. 2 plus x, she says. Do you guys want to agree with her?
Yes.
Anybody want to write it a different way? 2 more than a number. I'm going to say there's another way. Does order matter in addition? Oh, then how could we write it?
X plus 2.
X plus 2. Can't count it wrong if we write it like that because that means the same thing. 2 needs to be added to some number. Doesn't matter who gets to go first though, because addition doesn't care. A number more than 2. Sylvia, how do you think I could write that? A number more than 2. Okay. Derek, how do you feel? You think there's another way we could write that?
Yeah.
Okay, what would that be? Order doesn't matter in
2
addition.
plus x.
Yeah, order doesn't matter in addition. No one's not more important than the other. Okay. Product of a number and 6. How can we write that? Tyler? 6 times x. Okay, well, we have to be really careful when we do times, don't we? What do we use now that we're such great algebraic scientists or something? I don't know. Caden. Dot. Multiplication dot. 6 times x. Yes, Danny? Or you could just write it 6x. You don't have to have the dot there, do you? Does order matter in multiplication? No. So I bet we could even do this, x times 6. Could we do that? Well, could we write it as x times 6 instead of 6 times x? Could I do that? Okay, here's one other way you will not see it. Do not write it like this. It's kind of like you're making up your own math language, and algebra says no, they're not going to let you add that to their books. You cannot write it like this. No. No. It doesn't even look good, doesn't it? Well, maybe only to a math teacher. Okay, don't do that. Okay, let's finish up that last one, number 8. 6 multiplied by a number. Harley?
Just put 6x.
6x? Or 6 times x? Or x times 6. Remember, order does not matter in multiplication. Yeah, okay. So, we have to make sure that we can set up algebraic expressions that replace words to be able to set up equations. Okay, so you're going to be doing some of that in the coming days. Okay, let's look at our other learning goal. This is going to be the fun one. I can determine mistakes made in solving equations. So you're going to find other people's mistakes so that when you make mistakes, you can find your own sometimes, okay? And I'm going to figure out how they should be fixed. Okay, so let's go to the back side and let's take a look at this first equation here. Finding mistakes. Where did they go wrong? Okay, so here is our original equation. Why don't you go ahead and just circle this. This is the original equation. So put that in your notes. So here's how it starts, and we're just going to follow along through their process of solving and see if we can figure out where they went wrong. Okay. Well, it looks like the next line says 6x plus 6 equals 36. Can anybody tell me what they did? The person solving it? Can anybody tell me what they did? It went from 5x plus x plus 6 equals 36 to 6x plus 6 equals 36. Idea?
They combine like terms.
They combined like terms. They combined the x's, didn't they? Did they combine them correctly? Yeah. Remember, it looks to me like they're getting the equation ready to solve. Did they do a good job? Okay. Then in the next step, so that's not where the mistake is, right? Then in the next step, we typically do it underneath. They did it off to the side. Here's what they did. They added a negative 6 to the left side. Well, if they did it on the left side, now they got to make sure they do it on the right side. They introduced something new into the equation, so they had to do it on both sides. Do you think that's what they should have done, is add a negative 6? Yeah, because what does that do? 0 pairs off with the 6, doesn't it? It gets that out of there. Okay, so now it says 6x is by itself, and on the other side we end up with 30. Did they do that right? So these guys 0 pair out, right? And is 36 plus negative 6 30? Would there be 30 positive tiles left if we added 6 negatives and paired them up with 6 positives? Yeah, there didn't go wrong there. Huh. Okay, well, how about the next line? Look at what they did in this one. They took both sides times 6. So what, 6x equals 30. What would we do? Would we take both sides times 6? No, what would we have done? Oh, they shouldn't have multiplied. So let's circle that right here. And here's where their mistake is. That's wrong. Don't do that. So what should they have done instead? What did you just say? Divide. Divide both sides by 6. And then I have an or there because I don't necessarily typically like to teach it this way, but I'm going to because we've already talked about reciprocals. Taking that 6x and dividing it by 6 creates a 1x for us. That's what we want, is a 1x. What's another way to get a 1? Multiplying instead of dividing. If the person who solved this wanted to multiply, what should they have multiplied by instead? What can you multiply a number by and get 1? Sylvia? Not 0. 0 gets 0. Starts with R. We learned about these. R-E. Reciprocals. What's the reciprocal of 6? 1, 6. So, or multiply, because you might see this when you're looking to fix them, and if you see that they multiply both sides by the reciprocal, that's not wrong. So that's the other choice that they could have made. Multiply both sides by the reciprocal of 6. So I don't want you to think that somebody goes wrong in that step if they didn't divide, but instead they multiplied by the reciprocal. It's just that they didn't multiply by the reciprocal, they multiplied by the 6. Okay, so let's go over here and fix that then. If we take 1/6 times 6x, and we take 1/6 times 30 instead, let's just do that. Let's do the reciprocal way. Just in case, you see this in your homework, or in your homework, you know what to do. Taking reciprocals times each other, leaves it as x. But now we have to figure out what is 1/6 times 30. So let's make 30 into a fraction by putting it over 1. What's 1 times 30 upstairs?
30.
30. What's 6 times 1 downstairs? 6. So now we have to figure out how many times 30 can be divided by 6. Is that what you're saying? It's 5? Okay, 5. X equals 5. That's what the answer should have been instead of their 180. They're wrong, aren't they? Okay, the other thing we could have done is we also could have divided. So 6x, this is what we would have probably most likely done, most of us. But either way, we're going to get the same answer, right? Doesn't matter. Because we said you could do either or. Okay, so let's move on to one more of these and see if we can find the mistake. Here's our original right here, okay? Original. Original equation. Is it ready to solve? If we were going to solve this, what would we have to do? We got some combining of like terms we could do, couldn't we? Okay. Well, we would probably rearrange this first. I don't know if they did or not. Let's see. If we were going to do this, it would be x plus what? Harley? Huh?
Okay, so after the original column,
Mm-hmm.
how there were 3 and there's 4 or 2 x's. I don't know how they got 3x because that's not times x.
No, so that's where their mistake is, right there. This is where their mistake is. They went from 3 plus x and they made it into a multiplication problem. So this is where our problem is, right here. This is it. This is wrong. We can't do that. It was 3 plus x, not 3 times x. So we're going to go over here and start fixing right away. We don't even have to look at that anymore. It's already wrong. So we're going to say, here's what they should have done. Let's rearrange it so that the x's get to be beside each other. Remember how we group like terms? And the 3 and the 1 get to be beside each other. Because then we will be able to get the right new name for our equation. What's x plus x plus? 2x. What's 3 plus 1? 4. Okay. And And now what are we gonna do? Is it time to solve it? Can we do any other stuff to it, to rename it, Ikea?
Add negative four.
Yep. So in other words, it's time to solve it, isn't it? We're gonna add -4 to both sides. And we're gonna get, this is gonna zero pair out, and we're gonna have 2x equals what? 13. Now what are we gonna do? Divided by 2. Now what are we gonna have? Danny? 6.5. I bet when you go over off to the side and take 13 and divide it by 2, you're gonna get 6.5, also known as 6 1/2. That's the other way we could name it. They got 4, we got 6 1/2. So what should they have done instead? Let's just put an arrow up here. So we don't have to write it all out. Apparently that's where I wanted to do it, but. Okay, so now we find the mistake, but do what?
Tell me why.
Fix it, right? We're fixing it and getting what the solution should be. Now here's the crazy part. Sometimes when you guys do your problems, you do the wrong work, but you get the right answer. Do you suppose that can happen to some other people too? Could they have the wrong work, but yet they still have the same answer you got when you tried to fix it for them? Yeah, but you still sometimes need to just fix the work. Even if the answer turns out the same, we can't get away with having bad work.